Hi, grade 10s. Today we're going to talk about parallel and perpendicular lines. So let's talk about parallel lines first. Lines are parallel if they have the same slope and if they don't have the exact same y-intercept, then they do not intersect ever. The graph to the right has a pair of parallel lines. So these lines are parallel. And these lines will never meet, they'll never touch because they're parallel. They'll just keep going and they'll always be that far apart from one another. Okay? Parallel lines have the same slope. That's the major takeaway. Parallel lines have the same slope. The slopes are equal. Okay? Maybe it's 2/3, maybe it's -7/4, but the slopes are equal for parallel lines. Okay? Now let's talk about perpendicular lines. Lines are perpendicular if they intersect at a 90-degree angle. Okay, so I'll give you an example here. These lines do not meet at a 90-degree angle. They meet, but they don't meet at a 90-degree angle. Therefore, they're not perpendicular. Okay, so lines can be parallel, they can be perpendicular, or they can be neither. Okay, perpendicular lines have to meet at a 90-degree angle. And here's the kicker. The product of their slopes is -1. So if you multiply their slopes, you're going to get -1. Okay? If you know the slope of one line and you want to find the slope of a line that's perpendicular to it, you take what we call the negative reciprocal. What's the negative reciprocal mean? Well, the negative reciprocal means change the sign, flip the fraction. We all know what reciprocal means, or should remember what reciprocal means, because it's the idea when we divide fractions. When we divide fractions, we change the sign to multiply, and we flip the second fraction upside down. So really, it's the same idea, except we're changing the sign as well. So if the slope of one line was, say, 2/3, okay, if the slope of one line was 2/3, and we wanted to find the slope of a line that's perpendicular to it, we would change the sign to negative, and we'd flip the fraction upside down. Now it'd be 3/2. So those two lines are perpendicular, always, okay? So you change the sign and flip the fraction, and that'll give you a pair of slopes that are perpendicular, okay? Horizontal and vertical lines are perpendicular to one another. So for example, the x and y axis are perpendicular. And we have two lines here, this line here, and this line here, that are also perpendicular. They meet at exactly a 90-degree angle, okay? So they're perpendicular as well. Example, and this is where this stuff gets a little bit dicey. Write an equation of the line parallel to 2x plus y minus 7 equals 0 and through the point 3, 3. So as we discussed earlier, we need two things to make an equation of a line: the slope and a point. Well, here's the point. Where's the slope? Well, the slope is parallel to this line. So we need to find, parallel means equal, right? They have the same slope. So we have to find the slope of this line. How do we do it? We rewrite it in the form y equals mx plus b, which is what we did yesterday. So y equals -2x plus 7. So from that, we see that the slope is -2. So the slope of our line is going to be -2. So the slope is -2, and the point is 3, 3. So we go y minus y1 equals m times x minus x1. So y take away 3 equals negative 2 bracket x take away 3. And then we just use the distributive property on the right side of the equal sign and bring everything over to one side and see how it all plays out. So y minus 3 equals negative 2x plus 6. If we want the x to be positive, we got to take everything over to the left side. So 2x plus y minus 3, but then the 6 becomes minus 6. So we're going to have minus 3 and minus 6, which together gives us minus 9 equals 0. There it is right there, okay? So just to recap what we did here, we are given the point in the question. We are not given the slope directly, but we're told that the slope is parallel to the line that I highlighted in green. So what we have to do is we have to rewrite that line that I highlighted in green in y equals mx plus b form and slope y-intercept form, which we learned about last class. Once we do that, it's clear that the slope of that line is negative 2. So that tells us, because our line is parallel, that our slope is also negative 2. So you plug in the slope of negative 2 and the 0.33 into the point slope form of the line, and there you go. That's it. That's all. Okay? Next question. Write an equation of the line perpendicular to 2x minus 6y plus 12 equals 0, and through the point negative 5, 1. So again, we get a point, and we have to find the slope. But our slope this time is perpendicular to this line. So we have to find the slope of that line, and then find the line that would be perpendicular to that, or the slope that would be perpendicular to that. So again, in order to find the slope, we have to put it into y equals mx plus b form. So 2x plus 12 equals positive 6y. Then what we're going to do is we're going to divide everything by what? 6. So it's 2 over 6x plus 12 over 6 equals y. 1/3 x plus 2 equals y. So my $1 million question to you is, what's the slope of the line? It's 1 over 3. Yep. The slope is 1 over 3. But our slope's perpendicular to this. So our slope, how you say perpendicular, or the symbol that you use to write perpendicular is like 2 lines meeting with a 90-degree angle. So what I'm going to do down here is I'm going to say that m with a little thing like that, which just means that I'm looking for the perpendicular slope. The perpendicular slope just looks like this right here. Okay. The perpendicular slope to 1/3 would be what? What would be perpendicular to 1/3? What would be perpendicular to 1/3? Giddy up, it's negative 3 over 1. Now anything over 1 is just itself. So we can just rewrite that as just negative 3 and we're all good, okay? So the slope that we want in our question is negative 3, okay? It just means that it's perpendicular. Yeah, I know, it's that right there. Okay? Now, find the equation. So, y minus y1 equals m times x minus x1. So y minus 1 equals negative 3 bracket x plus 5. We expand and simplify the right side of the equation, and no, we're putting the x coordinate for x1 and we're putting the y coordinate for y1. I'm not. Well, that is adding there, but it's minus negative 5. Minus minus makes a plus, yes? X minus negative 5 is x plus 5. So we get negative 3x minus 15. And then because x is negative, bring it over to the left side so x is positive. So we get 3x plus y. The minus 1 is minus 1, but the 15 comes over and it becomes positive. So negative 1 plus 15 is going to be plus 14 equals 0. Done. Another example. Slopes 3 and m over negative 5 are parallel. Find the value of m that makes this true. So again, parallel lines are what? What can you tell me about their slopes? They're the same. In math, if something's the same, we say that it's equal. Very good. 3 equals m over negative 5. So now it's a trip back to grade 9 where you learned how to solve equations. And 5. And we're going to take both sides of this equation and multiply by negative 5. So when we do that, we're going to see that m is negative 15. Done. Okay? Next one. The slope's 20 over k and negative 1/2 are perpendicular. Find the value of k that makes this true. So what can you tell me about perpendicular slopes? This is a little trickier. Yep. What else can you tell me? Do you have a 90-degree angle? Sure. But it's going to be hard to measure that right now because we have no angles. Or lines, rather. The product is negative 1. That's right, product of their slopes. So we multiply these two things. That's 20 over k times negative 1/2 equals negative 1. Again, we're making ourselves a little wee equation, and we're going to solve for k. So we get negative 20 over 2k equals negative 1. Cross multiplying, we're going to get negative 20 equals negative 2k. And negative 20 divided by negative 2 is k. So k is 10. Any issues with that? Okay, we saved the best for last. Plot and join the points A, B, C, D in order on a grid. Classify each figure as either a square, rectangle, parallelogram, or trapezoid. Give reasons for your answer. So before we even start this, we better know what the difference is between squares, rectangles, parallelograms, and trapezoids are. So what makes a square a square? What can you tell me? 4 equal sides, okay. What else? Four equal sides and yes, equal sides and 90-degree angles all four corners. Okay, that's a square. Okay, that's a square. So we're just going to start off by writing this down because you're going to have homework on this stuff. So square, all sides equal. Now, we're talking about parallel and perpendicular lines today. Perpendicular 90-degree angles, right? Perpendicular 90-degree angles. All sides are equal, and all sides are, oopsies. Yeah, no, perpendicular. Perpendicular to adjacent sides. Like if you look at two sides beside one another, they're perpendicular because they all meet at 90-degree angles. So that's a square, okay? That is a square. That makes a square a square. What makes a rectangle a rectangle? Well, what's a rectangle? Pretend like I'm an idiot. Two pairs of equal sides, okay? Two pairs of equal sides, so parallelogram. Oopsies, I don't know what I'm talking about. Rectangle. A rectangle has two pairs of equal sides. All sides. All. Let's actually do this right here. All adjacent sides are perpendicular, which means there's 90-degree angles everywhere. I don't know if you've figured it out yet, but once we've done defining these, what we're going to do is we're going to go find the slopes of each of the four sides and the distance of all the four sides, so we can answer this question. But that's where we're headed. But before we head there, we have to know what defines each of these objects, right? So, a parallelogram, and actually, I'm just going to write another word here, rhombus, and we're going to do all five of them. We're going to look at all five of them here. We'll do a parallelogram first, though. Okay. So parallelogram. A parallelogram is like a rectangle that's been like tipped over. So it also has two pairs of equal sides, but adjacent sides are not perpendicular. Okay. So it's like a rectangle, but adjacent sides are not perpendicular, which means there's no 90-degree angles in a parallelogram. Okay. Now that being said, I just want to just preface this with saying this, like a rectangle is technically a parallelogram. And a square is technically a rectangle, and a square is technically a parallelogram. But we don't have to get into that kind of conversation today. Yes. Now we're going to talk about a trapezoid. A trapezoid. A trapezoid has two parallel sides. They're not equal. That's all we know. Two parallel sides. That's it. Two sides that are parallel. In other words, you'd have two sides that have the same slope, but none of the distances would probably be the same. Now, a couple of the distances might be the same, but they don't have to be. You just have to have two parallel sides that are separated from one another. That makes a trapezoid. Okay. Now, the last thing we want to talk about is a rhombus. The rhombus is to a square like a parallelogram is to a rectangle. A parallelogram is a rectangle that's just slanted a bit. So a rhombus is like a square that gets slanted a little bit. So a rhombus also has all sides equal, but adjacent sides are not perpendicular. Okay. So those are like 5 of the very most common quadrilaterals and what defines them as such. Now what we're going to do, once we've finished writing that down, is we're going to figure out what the 4 distances are and the 4 slopes are. But first, let's actually plot the points. So here we go. A is 2, 5. So A would be like right here. That's A. B is -2 and 4. So that's right there. C is -1 and 0. That's there. And D is 3, 1. So that's right there. So what you would want to do is connect these with something straight and have an idea of what you're looking at here. Now, are we looking at a square, a rectangle, a parallelogram, a trapezoid, or a rhombus? Well, and again, I like that some of you are jumping on an answer right away, and that's good. You do realize if you get a question like this on your quiz on Thursday or on your test later on in this unit, you can't just eyeball it. You got to prove it mathematically, right? So let's do that. So we'll start off with slope will be easier, I think. So let's start off with slope. Okay. Let's start off with slope. The slope between A and B. We could cheat a little bit with slope because we're going to use rise and run. Okay. We're going to use rise and run. Where's A? Yeah, okay. Rise would be 1, run would be 4, right? Rise would be 1, run would be 4. So the slope is 1/4. Done. Then we would look at the slope of BC. BC go right here. Okay. The rise is down 4 over 1. So it's -4 over 1. That's the slope of the side BC. Now, what's the slope of the side CD? Well, up 1 over 4. So rise 1, run 4. So 1/4. And now we're going to look at the slope of AD. And down 4 over 1. So again, it's -4 over 1. Those are the slopes. So what can you tell me about the adjacent slopes here? Are they parallel? Are they perpendicular? Or are they neither? They're perpendicular. Okay, so that should tell us one thing. Okay, that should tell us one thing. It's either going to be a square. Actually, it's going to be a square or a rectangle. Yeah, it's going to be a square or a rectangle. We just have to know if those sides are the same. And yes, we have to find all 4 distances to really know that. But okay. So, okay, distance between A and B equals. And hey, I don't know. I want to write that formula down because I don't want to forget it. So, if I look at AB here, 4 minus 5 and -2 minus 2. 4 minus 5 and -2 minus 2. We can see that the side length AB has a length of the square root of 17. 17 is not a root that can be simplified, so we are finished with side A, B. I'll give you a second to finish writing that down, and then we're going to find 3 more distances, BC, CD, and AD. Well, easy. Go to the next page because it's blank. That's how. So now we're going to find the distance between B and C. And again, I'm going to write the formula down. Because if I write it down a few times, I'm not going to forget it. So, BC. 0 minus 4 and negative 1 minus negative 2. Okay, so what do we get? Zero minus 4 squared. Well, it's just going to be negative 4 squared. Negative 1 minus negative 2 is going to be positive 1. So that's 1 squared. Distance between B and C is going to be 16 plus 1, which is equal to square root of 17. Oh, nope. Gotta find all 4 sides. We just found 2. Yep, really. So let's find the distance between C and D. You think you know what the answer is going to be. You have to prove it by knowing all of them. So let's do it. Okay, CD. 1 minus 0, 3 minus negative 1. 1 minus 0. 3 minus negative 1 squared. 1 squared plus 4 squared. 1 plus 16. Square root of 17. Now, this might not be a complete surprise to any of us, but we gotta do it. And we got one more side to do. And that should verify that all 4 sides are the same. And because we have adjacent sides being perpendicular to one another, we'll be able to conclude in just a minute, I hope, that ABCD represents a square. But we still have to do one more distance before we can absolutely say that. All right, so let's do it. We're going to do DAD, otherwise known as the distance between A and D. X2 minus X1, quantity squared, plus Y2 minus Y1, quantity squared. Okay, 1 minus 5 and 3 minus 2. 1 minus 5 squared plus 3 minus 2 squared. So we get negative 4 squared plus 1 squared, which is 16 plus 1, and that gives us square root of 17. Surprise, surprise, surprise. Not really. So now that we're done that, we can say, and this is important, because we can't just say it's a square. Okay, well, why is it square? What we say is we could say since all sides are equal and all adjacent sides are perpendicular, we have a square. Okay? It's a lot of work, but that's what we have to do to see what kind of shape it's going to be. Okay? Not likely to see something that involved on a quiz, but you could see it on a test. All right, it's homework time.